In addition to verifying that points are rotated, we can also use the distance formula, or really Pythagorean theorem, to find other points created by rotation. So I have point A, which is 4, 2, and it's rotated about point B at 1, -2. So I'm going to go ahead and rotate that to create a point in comma 1. So what am I trying to do here? I'm basically trying to figure out a point that's the same distance to B as it is to A. So if I go ahead and calculate the distance from A to B, which I will using Pythagorean theorem, I find out that the distance is 5. Okay. Now, looking at the point, it's going to be at n, 1. That means it could be at 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, etc. So it could be any of those. But the main thing is that it needs to be a distance of 5 from B. Well, all those points fall on this line. And if I go ahead and add a point to this line, which I'll go ahead and do right now, and connect it with a segment, you're going to notice that as I move this point around this line, for sure it better not be over here because that's too close to B. It's not 5 units away. It probably shouldn't be out over here at 10 and 11. That's definitely more than 5 units. So it's going to be somewhere in here. So how can we verify what it is? Okay, well, let me first of all highlight the distance from B to this line. That distance is 3. Well, wait a second. When I did the vertical and the horizontal distance, a 3, 4, 5 is a right triangle. So if I go 5 units out, we'll go 1, 2, actually 4 units, 1, 2, 3, 4, 5. Well, did I count that right? 1, 2, 3, 4. I'm only going 4 units out. Then that should match right up with the distance of 5, and it does. So I've just found out that the value of n is 5. A figure, the one other thing I wanted to talk about is rotational symmetry. So basically, if I can rotate it in less than 360 degrees, it does have that symmetry. Everything has 360-degree rotational symmetry because anytime you do 360, you're back where you started and you get the same image. So here I have a figure, and I'm going to determine if it has rotational symmetry, reflectional symmetry, or both. So let's first hit upon reflectional symmetry. And that basically means when I can, the easiest way is if you can fold the object and it folds, each half matches exactly. So here are a couple different lines of reflection, and you're probably going, oh, those are a lot. And they are. If I use this line right here, you can see if I fold it, D goes on to E, C goes on to A, and B goes on to B. So it matches perfectly. If I fold it over line H, D goes on to A, C goes on to B, and E goes on to E. So this definitely has reflectional symmetry. There are 1, 2, 3, 4, 5 lines of symmetry, which kind of makes sense. Look how many vertices there are. Okay, now we're going to find out if it has rotational symmetry. And basically, if you are able to rotate it and it matches up exactly, which it will, 5 times as I rotate it through 360 degrees. So this also has rotational symmetry. So for further reflection, what is the difference between rotational and reflectional symmetry? How do you know you have symmetry?